All right, exponent rules. These are very similar to the exponent rules that you saw in practice test number 1. A couple of them are a little more challenging than problems that you will see on the entrance exam, but it's safe to say if you're comfortable with these, you will be comfortable on the entrance exam. Number 8, we're doing same base and we're multiplying, so we're going to add our exponents. And I like to show that, just like that. I just need to add. So I'm going to take it to 1 base, 3x, plus 1, plus 5. So my exponent becomes 3x plus 6. There's nothing more to do there unless we know what x is. So we're done. Just make sure, same base and you're multiplying, you add your exponents. Whether you just have a 2 and a 3 there, and you're making it n to the 5th, or whether you have a variable in there as well. Same base, or here we have power to a power, and when we do power to a power, we multiply. And if exponent rules are something that you struggle with, I totally understand. Exponent rules, there are only 3 operations that you're doing, really, adding, subtracting, or multiplying. But it can be very challenging to remember what to do when. So just writing out the rule that you're using hopefully will help you. That's really the thing that I tell all of my students, because I teach exponent rules kind of at all levels. When in doubt, write out, like if you're struggling, write out the rule that you're using, and hopefully that'll help you remember it. So negative 3 times 8 is negative 24. And we're writing all of our exponents as positive. And the reason we're doing that is so that we can be fluent with those exponent rules. So when we get to AP Calculus and we're using exponents, we can make the decision. Do I want a negative exponent in the numerator? Do I want a positive exponent in the denominator? Which one is better for my situation? Here, when we flip that x to the negative 24th down to the bottom, we make that exponent positive. All right, last one on this page. Again, we're multiplying in. Here's what I like to do, especially when I have more than one thing in my parentheses. I have x to the 4th, I have y to the 8th. That 3/4 is going to become an exponent on both. So I'm going to multiply it in. I like writing it out in that order. That really helps me this year and a couple of my students kind of make sure that you're applying that exponent outside of everything you need to. And now we multiply. When we're multiplying with fractions, we just multiply across and then divide. 4 times 3 is 12. Divided by 4 is 3. 8 times 3 is 24. Divided by 4 is 6. X to the 3rd, y to the 6th. Never bad to do a little fraction work. Speaking of fractions, again, I'm going to go ahead and recopy this guy before I bring that 2/3 in. It does work a little bit differently here. So it's a negative 2/3. So I think what I'm going to do actually first is since this negative applies to everything, I'm going to flip my whole fraction. And then I can deal with a positive exponent. So I'm going to move the 27 to the top and the 8 to the bottom and make that a positive 2/3. Now I have every piece living in the right part of the fraction. When I'm working with a fraction exponent, here's what's going on. The 2 is the power. The 3, the bottom, is the root. And for me, it's always easier to take the root before I do the power. That order doesn't matter, which is lovely. So what I'm going to do, so the top and the bottom, is I'm going to do the cubed root before I square everything. And I have to do that to the top and the bottom since that whole fraction is in the parentheses. It's much easier to knock our numbers out by taking the root first. So the cube root of 27 is 3, and 3 squared is 9. The cube root of 8 is 2, and 2 squared is 4. And that's your final answer. Again, number 12 is just a little more complicated than anything that you'll see on the entrance exam, but it's great fraction work, great exponent rules work, and great precision work. If you can get through this one, you are pretty golden on your exponent rules. The first thing I'm going to do is bring all of these outside exponents in. So if you could, pause and try to get that done on your own, and I will catch up with you. All right, hopefully you try that. Here's what I'm going to do. I'm going to go ahead and just for these first two, I'm going to recopy. It's x to the first and y to the first, and I'm bringing in that 1/4 on both. And my second set of parentheses here, I have x squared and y squared. And I'm bringing that 1/2 in. If you feel good skipping this step, that's great. I'm going to show it. I have x squared and y in the denominator, and I'm going to bring in that 3/4 on both. And my next step is going to be cleaning up all of that multiplication. So in my numerator, I have x to the 1/4 and y to the 1/4. 2 times 1/2 is 1. Same thing here, 2 times 1/2 is 1. All right, we're getting better, not so messy. And the denominator, I'm going to, you can either multiply across and then kind of clear things out. Actually, as I'm looking at what's happening in my numerator and what all of my fractions are going to look like, I'm going to keep that 4 on the bottom for a common denominator. So I'm going to go ahead and just make this x to the 6/4 and y to the 3/4. Then I'm going to kind of evaluate what I have going on here. The reason I left that, I could have reduced 6/4, of course, to 3/2. But since I saw I'm going to need to combine my fractions both in the numerator, or I'm sorry, combine my like bases in the numerator and across that fraction line. So I'm going to have to do some subtraction of those exponents, and so I'm going to need a common denominator. All right, the last thing I'm going to do here is change these ones so I have a common denominator. First, I'm going to add in my numerator, so I'm going to change these to the first powers to 4/4. Because when I have the same base and I'm multiplying, I'm going to add those exponents. So here's what this is going to look like. I'm going to do x to the 1/4 and x to the 4/4. So those are dealt with. I'm going to do y to the 1/4 and y to the 4/4. Yeah, when we have the same base and we're multiplying, we add our exponents. And to add fractions, we need common denominators. The denominator, I'm just going to leave down there for a minute. In my numerator, 1/4 plus 4/4 is going to give me 5/4. Just going to recopy that denominator there. And now I can subtract. Since I have the same base, I can subtract my exponents here. So I'm going to do 5/4 minus 6/4 on my x's. That's going to give me x to the negative 1/4. I'm going to do 5/4 minus 3/4, and that's going to give me y to the 2/4. Last step, This guy needs to go to the denominator so that I have a positive exponent. And my y to the 2/4, I'm going to write as y to the 1/2 power. That is a lot of work for a little exponent rules problem, but it is great precision work. Again, if you can get through that, your exponent rules you've got it on lockdown, so great job.